Hello, we're going to be doing the Grey Kangaroo, which is one of the math challenges that happens if you like in the top something percent. It's like the next round of the intermediate math challenge. It was just a couple of days ago, actually. We're going to try it out, see how it goes. Never done a Grey Kangaroo before, so don't know how tricky it is going to be. But let's see what happens. We've got a timer up here. Let's start. Okay, let's see how it goes. I think we get an hour. So, which of the shapes below cannot be divided into two trapeziums by a single straight line? What? The triangle. Wait, how can any of these? How can any of these be divided into two trapeziums? What? I can see one trapezium. How can you make another one? How can you make one here? Oh, because there's a rectangular trapezium? That's two trapeziums. That's two trapeziums. Is a rectangle? Okay, we're going for triangle, but what the? That's hard straight away. What's the sum of the largest three-digit multiples of 4 and the smallest four-digit? Okay, the largest three-digit multiple of 4. Now, that's going to be 9, 9. Now, for it to be a multiple of 4, the last two digits have to be a multiple of 4. So 9 plus 7. That's a multiple of 4. And the smallest four-digit multiple of 3. So that would be 1, 0, 0, 2. Digits are multiple of 3. So the difference is, the sum, 1999. Oh, God. When he wants to write a number on each vertex, on each edge of the rhombus shown, he wants the sum of the numbers, two vertices. The sum of the numbers at the two vertices to be equal to the number written on the edge. What? A number on each vertex and on each edge. What's the sum of the numbers at the two vertices to equal the number written on the edge? What number should go here? A, B, C, D. Okay. D plus C equals 8. C plus B equals 9. A plus B equals 13. So what's A plus D? What's happening here? If I add all these, I get A plus D plus... Okay, plus 2B plus 2C equals to 30, but 2B plus C is 18, so A plus D equals to 12. So that's a 12. Okay, sure there's a better way to do that. Christina has a piece of transparent paper with some lines marked on it. Fold it along the central dashed line. What can she see now? Oh my word. Okay, so this guy goes, I'm going to zoom. This guy goes here. This guy goes here. This dot, okay, no idea. This line is all of this. This is there. This is here, and this is there. 569. Oh my god. Okay. That wasn't that bad. John has 150 coins, but he throws them on the table. 4 of them show head, 6 of them show tail. Sorry for just bouncing around. Okay, 4 of them show heads. So currently we've got 4 tenths. So we've got 150 and we've got 60. Okay, I know actually I need to set it up. So 40% is 60. So we've got 60 to 90. How many coins showing tails do you need to turn over to have the same number? Showing heads, tails. If he turns over 15, then he gets 75, 75. Okay, that's not bad. 5 circular discs, each of different sizes. She decides to build a tower using 3 of her discs. Each disc is smaller disc below it. How many different towers can? Using 3 of her discs. Okay, so we've got A, B, C, D, E, like this. If you start with A, then there are 1, 2, 3, 4 options for this one, and then 3 options for that one. wait. Okay, wait, what? If you start with A, then there are 5 options. You can either go B, C, or D. No. Okay. If you start with A, then you can either do B, C, or D. So you can either go B, C, or D. If you go B, then you can either go D or E or C. If you start with C, you can go D or E, and if you go for D, then you go E. This is definitely not how to do this one. Okay, if you start with B, oh, it's like, okay, I kind of see what's happening here. If you go B, then you can either go C or D, and if you go D, you have to go E, and if you go C, you go D or E. You can't have D or E. You can't at the bottom. So C, the only option is D and E. So overall, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options. Absolutely no idea how to do that in a better way than that terrible way I just did it. Okay, Avita wants to write the numbers 1 to 8 in the box to grid below, so that the sums of the numbers in each box are equal, in each row are equal. Let's write the numbers 1 to 8 so that the sums of the numbers in the box in each row. So that's A, B, C, D, E, and that is M, and M, and that is N. Okay, let's do some rub it outs. I'm not doing this very fast at all. This seems very hard, this one. Okay, ordering numbers default. What number should we write in the shaded box? Okay, so A plus 3 equals D plus 4 equals B plus 8. And A plus B plus C plus 4 equals 11 plus D plus E. Equals C plus E. Okay, so I mean, we're trying to find C. So oh, and it's just the numbers 1 to 8. Okay, well, I think I'm being too general. Let's just try it. Numbers 1 to 8. So I think they all need to go to 9, I feel like. And then it's like a 7 and a 2. So it's either a 7 or a 2. This seems to 13. I think this is the wrong way around. I think this needs to be 7 and this is a 2. 10, 18, 10, yeah, 7. Okay. That's just a, yeah, don't do algebraically. Okay. Theodorica wrote down 4 consecutive positive integers in any order. 4 consecutive positive integers. Okay, we've got A, B, B, and then C, D, D, and then C, D, A. Okay, so it's like something in 99 going to 100 going to 101. So it's 199 going to 200 going to 201. And so 202 is star, heart, triangle, heart. That's really fun, actually. I like that. That's a really nice puzzle. Okay, 5 equals semicircles lengths. What's the radius of each semicircle? D. Okay, 22 plus A equals to A plus B plus 12 equals to B plus C plus 16 equals to C plus D plus 12 equals to D plus 22. So C has to be 10. If that's 10, then B has to be 6. Oh wait, okay. B has D plus 22. B, wait, what? Wait. 22 plus A, so B has to be 10. 10. So the whole, so it's 26. No, 36. No. Oh, it's the radius, so it's 18. Oof. 22. Yeah, I think that's right. A and D are the same. Oh, there's definitely better ways of doing this. But I'm pretty sure the whole thing's 36, and so it's 18. Oof. Okay, we're making slow progress. Some edges of a cube will be coloured red, so every face has at least one red edge. Some edges of a cube, let's just draw one, so some idea what I'm doing. Oh no, I've drawn them all red. Shall we be doing this as a net? Maybe I'll do this as a net. Okay, now I'm helped by the fact that I can use different colours. Let's do blue, so that every face has at least one edge. So one red edge. There, that's one. I feel like it's 3. That one. And now these two faces do. Is it 4? If I do this edge here, then I don't think I need this one. Because if I do this edge over here, but then this guy doesn't have any blue ones. If I do this guy, I think it's 4. Nah, not too sure about that guy. Might be 4. Oh, it's bugging out. Hello? What's going on? Come on. Wasting time. Should I keep thinking about this? I'm going to say 4, but I'm going to circle it. Matchsticks can be used to write digits. As shown, how many different positive integers can be written using exactly 6 matchsticks? How many different positive integers? 6 matchsticks. Okay, can't be any 8s. That's too many. Everything else is fine. How many different correct? Okay, well, 1, 1, 1, that works. 1, 4 works. 4, 1 works. 1, 2, 3, 4. Okay, the number 6 works. The number 9 works. 77 works because they're 2 3s. 1, 2, 3, 4. So 41. Oh no, I've done that. 1, 2, 3, 4, 5. You can't do 2s with any. 1, 2, 3, 4, 5. Can't do 3s with any. 1, 2, 3, 4, 5. Can't do 5s with any. 1, 2, 3, 4, 5, 6. Done 6. 1, 2, 3. 7 has to match with a 3, and so it's just 77. 1, 2, 3, 4, 5, 6. Can't do that one. 1, 2, 3, 4 matches with 1, 1, and that's it. So I've done that. 1s, it's 1, 1, 1. 1, 2, 3, 4, 5, 6. And 0 is 0 positive integer. I don't have 0 as a positive integer. 1, 2, 3, 4, 5, 6. It's 6. Oh, they haven't added 7. So 0 is not a positive integer. Hey, 6. Wow, that's surprising. I thought it would be loads. A square with side length 10 is drawn on a piece of paper. How many points? Exact 10%. A square with side length 10 is drawn. Loci question? Got a 10, 10. how many points? Exactly 10 from 2 of the edges. So we've got 1, 2, 3, 4. That's from the, if you look at matching corners. It's going to be another on the inside. And then these are, okay, so we've got 1, 2, no, let's do a different color. We've got 1, 2, 3, 4, and then on the inside 5, 6, 7, 8. And then this point is also 10 centimeters away from sort of these. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, that feels wrong. That feels wrong, but we're moving on. In the diagram below, PQ are equal. PQ and P are equal. Also, QPR is 40. And T. Okay, so it's an isosceles triangle. So if that's 40, these add up to 140, so they're each 70. So 70 and 70, and that's X, and that's X. I would still probably want this bigger. Okay. 70 and X, 70 and X. What am I trying to find? TUR, TQ, P. Okay, so this is 70 minus X. This is 70 minus X. So this, okay, that's 180 minus 70 minus X and minus X. So this is 110. So this is 70. Okay, not bad. Quite fun. Tom, John, and Lily each shot 6 arrows at target. Arrow hitting anyone within the same ring score the same number. Okay, so Tom has 3 of the inner circle plus 1 of the second circle plus 2 of this circle, and it equals to 46. John has an inner circle and 3 outer circles, the 3 middle circles and 2 outer circles. That's 34. And we're trying to find what is 2a plus 2b plus 2c. Oh my god, the most classic math challenge question of all time, because when I add all of these together, this is Math Challenge's favourite type of puzzle here. 4a plus 4b plus 4c equals 280. So 2a plus 2b plus 2c equals 40. Okay, I need to make a collection of all the same, these are all the same. All these questions, they love this type of simultaneous equation question. Okay, that was cool. Let's go. Diagram shows a smaller rectangle is made from 3 squares. Each of the areas is 25. 25. 2 of the vertices of the smaller rectangle around the midpoint. Okay. Mid. What's the area? Okay, so this is 5, 5, 5, 5. We're trying to find, we can find that length. What's the area? Okay, we can find that length because it's just Pythagoras, so it's just 15 squared plus 5 squared equals to c squared. A little bit silly doing that. Math Challenge usually doesn't like such big numbers, but 15 squared, it's like 225 or something. 5 times 1, 7. Yeah, 225. So 250 equals to c squared. What? So c equals root 250? Ugh, what's that about? But then if this is 5. Am I being really silly? Is this just a fraction thing? Because are these similar? We've got this long length is root 250. So, okay, this length is root 250. Got these little these. Am I missing some information? And then this length is A. This length is A. This length is C. I feel like this is something weird. B, A. A squared plus C squared. No, I can't call it C. Okay, I'm changing my C. A squared plus C squared equals to 15 squared. Yeah, there's something fishy going on here. A squared plus B squared equals to 5 squared. Yeah, look, that's all these bits. So I bet it's like I've got A squared plus B squared plus, and so 2A squared plus B squared plus C squared equals to root 250. No, equals to 250. What am I doing? What am I doing? What am I doing? Okay, I think... Okay, I think this one is a start again sort of vibe. Oh, this looks cool. So why am I getting it wrong? Okay, so we've got... this. We know that this length, that length, which is the hypotenuse, is root 250. The area is AB plus AC. That's the area we're looking for, plus 75. But what is happening here? It feels like if I do this, like that, is that something? Like, that's just, oh god, I don't know. What is this? This length is 5, this length is 5, this length is 15, this length is 15. I'm trying to find the area of the whole thing. So I need A, B, C, C, B, A, C, C. So I've got A squared plus C squared equals to 25. I've got B squared plus C squared equals to 225. And I've got that A plus B, okay, one sec, root 250. So a squared plus b squared plus 2ab is equal to 250. Okay. Wait. If I add these together, I also have a squared plus b squared plus 2c squared equals to 250. So 2a plus b. Wait, why have I got 2a plus b? I think that's 2ab. 2ab. 2ab equals to 2c squared. ab equals to c squared. How's that helping me at all? At all? The area is BC plus AB. No, plus BC plus AC plus 75. Okay, this is taking way too long. Like, way too long. So this is the area we're looking for. We haven't used the fact that C is half of the thing. Like, at all. We've got this down here. I'm actually leaving it. Oh my god, that was really sad. There's something cool happening here, but I don't know. I'm guessing it's 125, but just because it's half of 250, so I don't really know why. Okay, the sum of 223 consecutive integers, 2020. What's the sum of the digits of the largest of these integers? So if we're to get to that, that means half of them need to be negative. Loads need to be negative. I'm looking at 16. So sad about that last question. Sum of what's the digit of the largest of these? If I add up loads of digits and I want to get to 2023. I feel like it's just 2023. I feel like it's just this. Because I feel like if you start from minus 2022 and you go up to 2023. No, that's way more than 2023 consecutive digits. Consecutive integers. Oh, that's way more. How do I get to 2023? Like, I kind of want everything to cancel and only be left with this. I need two consecutive numbers that add to make this. 1011, 1012. I think it's going to be this. Can't quite explain why, but I feel like you're basically going from minus 1011 all the way up to 1012. That is 2023 digits. And everything cancels except for this. No, that's wrong. That's wrong. When I add those up, I only have 1012. Maybe it's... How many digits is that? 1010 plus 1012 plus 0. I think that is 2023. I think here what we're left with is we're adding these two together. I think it's that. I'm going for it. 1012, which is 4. Ooh, math challenge got hard. Okay. Feel like it's that. Some beavers and kangaroos are standing in a circle. There are 3 beavers in total, and no beaver is standing next to another beaver. The kangaroos. What? So okay, so we've got a circle. We've got beavers. Beaver, beaver, beaver. No beavers stand next to each other. Exactly 3 kangaroos are standing next to a kangaroo. So there's a kangaroo here. There could be a kangaroo here. No, they can't. If there's a kangaroo here, so here we've got two kangaroos next to each other. So then I would only have room for, I could put a kangaroo here and a kangaroo here. But I can't. Look, as soon as I go to this, I now have 4 kangaroos. But if I get rid of that, I only have 3 kangaroos. I only have 2 kangaroos next to each other. I need 3. So basically, if I do this, then 3. If I do this, then 3 kangaroos are sat next to another kangaroo. This guy, this guy, and this guy. They're all separated. Get rid of the update, please. And no, okay, it's 5. Ooh, that's an interesting question, you know. Snow White organised a competition. Oh, I've only got half an hour left. Dwarf played 1 game with another dwarf. There was a similar question about this. Oh. Hello? Hello? Have I lost internet? No. I think I'm back. Okay, I'm back. Okay, losing time. Okay. Oh, I think it's triangle numbers, this question. There's something similar in the pink kangaroo. So there's 7. No, go away. So there's 7. 1, 2, 3, 4, 5, 6, 7. So total games 3, 4, 5, 6, 7 is 1, 2, 3, 4, 5, 6. It's 6 plus 5 plus 4 plus 3 plus 2 plus 1. 10, 21 games. There are 21 games. 1, 2, 3, 4, 5, 6, 10. I think you didn't play any. Oh no, wait. Wait, what? Dopey. They all play each other. Okay. They all play each other. So we've got A, 2, 3, 4, 5, 6, 7. They all play each other. But how can they all play each other? Doc played 6 games. Okay, is this Doc? Doc played 6 games. Grumpy only played 1 game. So let's just leave Grumpy there. Sneezy played 2. Let's call this guy Sneezy. Let's call this guy Grumpy. This guy needs to play 3 games. This guy's Sleepy. This guy needs to play 4 games. So this guy is Bashful. Happy played 5 games. 1, 2, 3. I messed up. Whoa, what the heck is going on here? Altogether, there are only 21 games of chess that need to happen. Because it's, yeah, only 21 games of chess. But they include Dopey. Doc played 6 games, so that's 3 lines. I think I've gone about this the opposite way, maybe. Start from the bottom, maybe? Okay, so let's start from doc. Okay, so my guy only plays 1 game. Bashful plays 2 games. Sneezy plays 3. 1, 2, 3. Doc plays 4. 1, 2, 3, 4. Grumpy plays 5. That can't work. Already we've messed it up. 1, 2, 3. Where are the other games? Oh, I don't know. I don't know as well. Ah, so sad. Okay, come back to 15 and 18. Absolutely no clue. Okay. The regions shaped below with 1 integer in each region. What's the product of the integers in each region have a common edge to be no more than how many weight integers? Product of any integers in each region have a common edge to be no more than 15. The product. So let's put 1 in the middle. Because then, oh wait, but if I put 9 can only go with 1. Same with 8. Yeah, if I put 2 here, you can't put 2 here. You have to put 1 in the middle. Because 2, okay. And then 7 times 2 and 6 times 2. And then 3 times 4 and 5. Cool. In how many ways can she do this? That's 1. You could swap the 8 and 9 around. That's 2. You could swap these around. That's... Wait. So there's 2 options for the 8 and 9. There's 2 options for the 7 and 6. 2 options for the 4 and 5. And then we can also swap these 2 around. That's 32, right? Oh no, it's 16. Any other swaps? I don't think so. It could be 32 as well. Could swap the 2 options for 8 or 9. 2 options for 4 and 5. 2 options for 7 or 6. And then 2 options for which way round the 4, 5, 3 and the 7, 2, 6. I think that's 16. That is also a cool question. There are twice as many children and adults sitting on the table. The age, so children to adult is 2 to 1. The age of each person at the table is a positive integer greater than 1. The sum of the age of the adults was 146. Okay, what? 80% less than the age of the whole. Okay, so C plus A how am I going to write this? Number of children. Okay, so the age of all the children, so the total age of the children plus the total age of all the... Okay. The children's ages plus the adults' ages all over the amount of children plus the amount of adults is equal to 80% less than the mean of the whole group. So this times 0.8. No. 80% less. So it's... This is equal... Wait, what am I doing? Okay, and then I have children's age over children. And if this is 80% less than this, how do I write that again? That's 80% of that. So this 0.8 times this is equal to this. So this is 10 over 8, like that. Okay. Now the age of all the adults is 156. The sum of all the adults, 156. And there are twice as many children as there are adults. So A equals C equals to 2A. So I've got CA plus 156 over 3A equals to 10CA over, and C is A over 2. Wait, C equals 2A. 2A. I can cancel out the A's, and then what am I trying to find? What's the sum of the age of children? So now I've got 2CA plus 312 equals 30CA. So now I've got 312 equals 28CA. Please God, can this, I think it is. So CA equals 312 over 28. No, this isn't nice. This is wrong. Because this is 156 over 14. What the heck is that? That is just wrong. Where's my 8 gone? I had a 10 over 8 here. I had a 10 over 8 here. And that's a 2A. It's actually a 16. So this should... If I cancel... Let's look back at this. Sum of the children plus 156 over 3, the amount of adults, is equal to 10 lots of the sum of the children ages over 16, the amount of adults. Oh, okay, if we do some cancelling, we've got CA plus 156 over 3 equals, that's 5 over 8. 5 over 8 CA. I mean, this still seems a bit weird. 8CA plus 8 times 156 equals 15CA. No, I've got multiples of... No. I've got 7CA equals 8 times 156. But 156 is not in the 14 times table. The amount of children is 2 times the amount of adults. Okay, so the sum of the children ages plus 156, which is the mean, that's the total ages, divided by the total number, which is children plus adults, is equal to, and now 80%, no, it's 80% less, so it's 20%. 20%. Oh God, it's 20. Why did I find that bit so hard? It's 20% of that equals that. So a fifth of that equals that. So I can just times that by 5. So CA plus 156 equals 5CA over C plus A. But I know that C equals to 2A because children is twice as much as adults. So CA plus 156 over 3A equals 5CA over to 2A. A's cancel. Now I've got 2CA plus 312 equals to 15CA. So I've got 312 equals to 13CA. Is this divisible by 13? Please, sweet Lord, please be. 0, 2, 26 into 5, 4, 24. Oh, wow. That was horrible. That was horrible. Oh no, I'm rubbing out important things. I kind of want that for later. I'm going to get rid of this. I'm going to get rid of all of this. This was all disgusting. All disgusting. Okay. I've only got 50 minutes to do all the hard questions. Martin's standing in a queue. The number of people in the queue is a multiple of 3. He notices he has as many people in front of him as behind him. So Martin is in the middle, and it's an odd number. And he sees someone behind him in the 28th place, and someone behind him in the 19th place. So now that means there could be 28 people here and 28 people here, which will make 56, which will make 57. Oh, behind him. Wait. I'm doing order wrong, I think. Yeah, because the 19th place would be here and the 28th place would be here. And then up to first place. So actually, he's closer than 19. So there could only be 17 people here. 17 people here. But that wouldn't work because that would make 35 people total. And that can't work because that's not multiple of 3. So I need to add, so if there were 16 and 16, that would make 33. That would work. So he could be the 17th person. Because there's 33 people total, 16 in front of him, 16 behind him. Okay, that wasn't bad. 17. Oh, that felt like I could have trial and errored that actually. That's fine. Whew. Okay, that's good. We got 40 minutes to do 3 questions on the ones before. Some mice living in neighbouring houses. Last night, every mouse left house moved to one of the 2 houses. Always in the street. Okay, so this guy went here. -1 to get to, and then I have 9, and then I need to lose 3. Wait, what? So if I lose 1 here, then this becomes 9. And then I lose 3 and this becomes 10. What? Every mouse left its house. Whoa, what the heck? I actually don't even know how to think about that. So I'm going to leave it and try the other 2. The last 3. Seven total, 19. So if he uses what? It ends in a 3. Okay, ends in a 3. So he has to use. There have to be 9 amounts of 7s on that last row. 2, 3, 4, 5, 6, 7. It ends in a 3. And then it carries forward a 6. And so that makes 63. That's the only way to get a 3. Is it that many? And now we need more 7s to get to a 0. Oh, but we don't know how many. Oh, okay. So this is 60. That's 2. Okay, so this is interesting. I need it to get to a 4, I think. So I think there's only 2 7s here. Because then I get a 0 here and a 2 here. And now I need to get to, oh no, 2023. Oh my God, I'm doing 2003. So I need to get to a 2 here. To get to a 2 here, when I add a 6, when I take away 6 from 2, I get 16. So I need a 6. So that's 56. So I need 8 of these. 1, 2, 3, 4, 5, 6. Wait, what? 1, 2, 3, 4, 5, 6, 7. Didn't need 9. Oh God. 8, 9. And now I only need 8 of the next one. 8 of the next one. Because this makes 63. And then 1, 2, 3, 4, 5, 6, 7. 8 times 7 is 56. Add 6 gets you to that. It only says how many times 77 occurs. Okay. So 56 add 6 is 62. So another 6 carries here. Now I need to get to a 0. I can only do that with 2 7s. And there we go. Ho ho! That was sick. That was a great puzzle. 1, 2, 3, 4, 5, 6. That was a great puzzle. That was a really cool puzzle. Love that. Yeah, sometimes it's worth skipping math challenge questions to get to things you might actually get. 6 connected numbers on 6 pieces of paper. You stuck these ones on the top and bottom of 3 coins. Okay, what? Okay, we know we've got 6, 7, and 8. Cool. On the first toss, you saw that. On the second toss, the sum of the numbers you saw were 23. Of all the 3 numbers were 23. So I don't think we can go down. If I do this, if I flip 3 coins, the maximum I can get is 21. So there aren't any digits below it. What? Is it just... Wait, what? There literally can't be a 5 here because 6, that makes 21. And he said the sum of the 3 numbers. What? Is it just 30? What? I haven't even used this. Oh, wait. Oh, no, wait. That doesn't make sense. But wait. Oh, no. Okay, I understand. I need to be able to make 17 and 23. So in this situation, I can't make 17. In this situation, I can make 17. In this one, I can't. But in this one, I can. 4, 5, 6, 7, 8, 9. Now, in this situation, can I make 23? Yes. Before I couldn't. So if I get rid of these, the last 3 digits are 18. That also wasn't hard. That felt like a, I don't know, like a Sudoku question, but I can't work out why. Rugby team scores 24 points, 17 points, 25 points in the 7th and 8th games of their season. What? Okay, so A plus B plus C plus D plus E plus F. That's the first 6 games. Plus 24 plus 17 plus 25. Over 9. And that is greater than A plus B plus C plus D plus E plus F over 6. And now they want their mean number of games to exceed... Okay. If I do 6 lots of A plus B plus C plus D plus E plus F... I don't think this is right, by the way. Plus, what's this? 49, 59, 66. Bigger than 9. Then if I subtract that, so I've got 6 times 66 is bigger than 3 lots of A plus B plus C plus D plus F. And then divide by 3, I've got 2 times 66 is greater than A plus B plus C plus D plus F. So those first few digits, these are bigger than 132, the sum of those scores. How on earth does that help me? And then, okay, then what I want is A plus B. These are bigger than 132. So let's say I've got 132 plus 66 plus the next game, which we'll call P, 10th game, over 10. I want this to be bigger because 132 is the smallest. These are bigger than this. That's the minimum. Smallest number of points they could score. And it's to exceed 22. So 132. I think actually the biggest these could actually be is 131, because it has to be less than 132. So I've got 197 plus P is bigger than 220. So P is equal to 23. Whoa. Whoa, if I've got that, that is crazy. Okay, I've got 5 minutes, and I haven't done 22, and I don't want to. It looks horrendous. I struggled with 15 and 18, and I was confused about number 10. Okay, I got 5 minutes. Let's try and do this question again. Come on. Okay. Let's go. Got this rectangle. We're trying to find the area of the larger rectangle. I know that this much of it, that's x, and that's x. That's x, and that's x. And I know that this length is root 250. So I know that the area is 2x times root 250. I know that. I know that. This area here is half of 75. Not that that helps. I also know that this length is 15 and this length is 5. So, look, for it to be an integer, I feel like I could try and narrow this. This is 5 root 10. And I need to times x by something. There needs to be a root 10 in there. I think it's got to be a multiple of 10. Can I have a root 10 times? I think it's just 100. I think it's 150 just by absolute cheating. Oh, I don't have answers for this as well, so I don't know if I'm right. Okay, when we get answers for this, I will add them to the end of the video somehow, so I can check. Yeah, so x times 10 root 10 is going to give me this length. Oh no, x times 10 root 10 is going to give me the area. And this is just always going to be a multiple of 10. Isn't it? Because yeah, it's got a factor of 10 in it. And the only answer here is it's a factor of multiple of 10 is 150. So it has to be 150, even though I haven't done any maths there. A, B, A, B. A plus B equals root 250. We also have x A plus x B equals my total area. X A plus B is my total. Oh, no, right. This plus the inside, 75, equals my total area. But I know that A plus B is root 250, so x root 250 plus 75 is equal to my total area, which is also the same as this. These are equal to each other. Oh, I managed to do it, I think. 2x root 250 equals to x root 250 plus 75. Take that away, I've got x root 250 equals 75. X equals 75 over root 250. Last 40 seconds. The area is, I've got, yeah, it's 150. Because it's, if I put it in here, I've got 75 plus 75, which is 150. Yeah, I feel like this also felt like it was half. It also felt like it was half. So, yeah. Okay. And I'm out of time. So that was really fun, actually. That was really cool. I really struggled at the beginning, I think, and then I got in a bit of a rhythm. So let's stop this, actually. Okay. That was really fun. Had a great time. Some more interesting than others. 14 is the most classic maths challenge question of all time. Couldn't do 18. There's something about those counting ones. Overall, there were 21 games. But I just couldn't work out what was happening. I felt like Dobie played... Yeah, couldn't work out what was happening there. And 22, absolutely no idea. Okay. Don't know if I've got those right, but I might have. I will try and add to the end of the video. When the answers come out, I'll try and add a section where I'm going through the answers to the video. That was super fun. I had a great time. Hope you enjoyed it. I hope you try it yourself. It's not available online yet. So when the answers are up, the questions will be up as well. So it will be available online for you to try. So hope you try it. Yeah, I mean, that's for year 9s. And I'm a math teacher. And in an hour, I didn't do everything because that was really hard. But yeah, also in the Kangaroo, you're allowed to guess because you don't lose marks. Not lose marks. So I probably would have guessed something. Okay, thanks very much for watching.